All right, section 5.3, we are talking about solving systems of equations by the substitution method. So for this method, we have some steps that we're going to follow on the top, and we can reference those as we're doing these problems. So the first thing you're going to do with the equations you're given is solve them for one of the variables, x or y. And it says pick the easiest one. As we do some examples, we'll talk about how to kind of determine which variable it might be easier to solve for. But you need to solve for one of your variables. So that means at some point the equation has one variable by itself on one side, and then everything else is on the other side of the equal sign. So once we have solved for a variable, we're going to substitute that value into the opposite equation, and then we're going to solve it. And then we're basically just going to do that same step one more time for the other variable. So I know sometimes it's confusing when you're just reading a bunch of steps, and it's definitely easier once you've actually done them. So let's actually get some practice with this. So to solve for x and y, let's take a look at example A. So we're given two equations. We have 2x minus 2y equals negative 4. And we have y equals negative 2x plus 5. Now, if we take a look, one of our equations is already solved for a variable. Our second equation is solved, is already solved for y. So that's step one already done for us. Solve for x or y, that's already been done. So we're done with step one. Step two says to substitute that value into the opposite equation. What that means is, I know y equals this, negative 2x plus 5. So what I'm going to do is I'm going to take this part and I'm going to substitute that into this other equation where I see y. So let me show you how we're going to do that. I'm going to take our top equation, I'm going to rewrite it, 2x minus 2, but instead of writing y, I am going to write... Let's do some highlighting here. I'm going to write this in place of y. So instead of writing 2y, I will write 2 times negative 2x plus 5. And then I'll still finish out the rest of the equation. So this equals negative 4. Okay? So all I've done is I've taken this top equation, I've rewritten it down here, except instead of writing the y, I wrote what I know y equals in this second equation, negative 2x plus 5. Now, why the heck do we do that? Well, we do it because now I have an equation with one type of variable, x. When I have an equation with two variables, I can't really solve it apart from saying one of the variables equals something with that other variable. But if I just have an equation with only one type of variable, in this case we only have the variable x, I can solve it for x and get a numerical answer. And that is what we want to do. So now that I've substituted that value in, if we take a look at our next step up here, after we've substituted, we now solve the equation. So that's exactly what we're going to do. You might notice we need to do some distribution here since I have 2 times a quantity inside a parenthesis. So after I do that, let's draw a line through the equal sign. I will still have my 2x here, negative 2 times negative 2x is going to give us negative 4, plus 4x, because I have a negative times a negative. And then negative 2 times 5 will give me negative 10. And this all still equals negative 4. You might notice we have some like terms. I have 2x and 4x. I will go ahead and combine those into 6x. I still have minus 10 equals negative 4. I want to get rid of this minus 10, so I'll do the opposite operation and add 10 on both sides. Once I do that, I have 6x equals negative 4 plus 10 is 6. This looks pretty nice. If I divide both sides by 6, since that number is being multiplied by x, you should get an answer with x equals 1. Okay, now we're not quite done. That was step 3. So now we know what our x value is for our solution. So we can go ahead and circle that. Now the only other thing to do is, oopsies, let me go back up here. We need to take that value that we just got, x equals 1, and step 4 says to substitute that value in to solve for the second variable. So I have two options. I can take x equals 1 and I can substitute it into for x in the first equation and solve it for y, or I can do it in the second equation and solve it for y. I'm going to choose the second equation because y is already by itself, so all I have to do is substitute my 1 in for x and then just simplify this side. If I put it in this equation, I'm going to have to move stuff onto the other side, and that'll just be more steps that I don't want to do. If you did do the first equation, you would still get the correct answer. If you don't, as long as you don't make any errors, you'll just have some more steps to do. But I'm going to do the second equation. So let's write this off. Man, I really took up a lot of room. I'm going to zoom in and do it up here. I can make it work. So now I'm taking my second equation here, and so I'm going to rewrite it. So I have y equals -2, but instead of writing -2x, I am substituting 1. Whoops, didn't want to select all that. I'm substituting 1 in for x. So if we come back up here, I will write y equals -2 times 1, and then the rest of the equation is just +5. So let's do some simplifying. Draw my line. Y equals -2 times 1. Well, anything times 1 is just itself. So that would just be -2, and then I have +5. So my answer is -2 plus 5, which is +3. So if I go back, if I can hold my screen, down here we had x equals 1 and y equals +3. That would be our final answer. We have solved for both of our variables. Okay? I know it looks like a lot of work, but you guys are more than capable of doing this. So let's take a look at another example here. Example B. We have y equals -4 and 2x minus 2y equals 0. So again, if I look at these equations, one of them's already solved for a variable. I have y equals -4. And that's even better than the last one because my y equals -4, there's no x involved at all. So this is going to be pretty nice as we do this. So this first step is already done for us. Y is solved for. Now we need to substitute that in the opposite equation. So let's rewrite that second equation, 2x minus 2, and then instead of writing y, remember, I am instead going to write -4. So 2x minus 2 times -4 equals 0. Now we're just simplifying. So 2x -2 times -4 is +8, so this turns into +8. Do the opposite operation, get that 8 on the other side. I now have 2x equals -8. Divide both sides by 2, and you should get x equals -4. Now, take a look at this. Our next step says to substitute this value in to solve for the second variable, but our second variable is already solved for. I know y equals -4. So if I plug the -4 that I solved for x back into this equation, I should get y equals -4 because I already know that's what it equals based on the given information. So I actually don't have any more work than I need to do. So I can just write y equals -4. Oops, that's not a good equal sign. Y equals -4. All right, let's do another one together. Okay, so I have y equals 4x plus 3 and -3x minus y equals 4. So again, I already see one of my variables is solved for. In that first equation, we have y equals 4x plus 3. So that is awesome because I'm going to take that and I'm going to substitute it for y in that second equation. So I'm going to rewrite that second equation. We have negative, oops, let's not use a highlighter. I have negative 3x minus, and then I'm going to write in everything for y. Now, it is an important rule of thumb. If you're ever using substitution for a variable, whatever you're substituting, surround it all with parentheses. Because notice, if I wouldn't have used parentheses, then this negative sign wouldn't have applied to everything. It would have just been minus 4x and then plus 3. But we have to minus everything that represents y. So that's why this entire piece has to be in parentheses, because this way the negative sign is going to end up getting distributed to everything inside. Okay, so very important. Remember to use parentheses. Okay, let's finish this. So negative 3x minus all of that stuff that equals y, and then this all equals 4. All right, now we need to solve. So again, if you see a negative symbol right in front of a parentheses like this, you can think of it as a -1, and we need to distribute that in there. So I'm going to rewrite negative 3x, and then -1 times 4x is negative 4x. -1 times 3 is just negative 3. And this all still equals 4. We have ourselves some like terms, so let's go ahead and combine those. You can use your calculator if you're unsure with those negatives, but negative 3x minus 4x is just negative 7x. Still have minus 3, still equals 4. Opposite operation, let's add 3 to both sides. And man, I should probably just start writing smaller. Now we have negative 7x, and this equals 4 plus 3, which is 7. All right, let's rewrite this up here. Oops, rewrite it up here. So negative 7x equals 7. If I divide both sides by negative 7 to get rid of the negative 7 being multiplied by my x, I now have x equals -1. Okay, so now we know what x equals. So again, we need to take this and substitute this value for x in one of these two equations. Now take a second, which one do you think is going to be easier? After looking at it, we're going to end up having to solve for y. So I'm going to choose the one that has y by itself already. So let's take this first equation, substitute our x value in for x, and let's solve it for y. So I'm going to rewrite that here in red down here. So we have y equals 4 times -1, because remember I'm substituting this -1 in for my x. And then we have plus 3. So 4 times -1 is -4. And -4 plus 3 is -1. Check it out. We got -1 for both of them. All right. How many do we have left? Quite a few. All right. Let's do one more together, and then I'm going to have you guys do E and F on your own. So look at D. All right, we can see we have this variable's already been solved for, y equals, and then a bunch of stuff. So we're going to take all of that, I'll highlight it with yellow, and we're going to substitute it for y in the other equation. So we have 3, we have 3x plus 3 times, and I'm going to use parentheses, and then everything that equals y in our second equation. So -3x plus 5. And this all equals 9. So I rewrote this first equation down here, except instead of y, I wrote what y equals. All right. Now now we got to do some distribution. Let's draw a line. So we should get 3x, and then if we distribute that 3 plus 3, or positive 3 times negative 3x is negative 9x, and then positive 3 times 5 is 15. We can add our like terms together. Those should combine to negative 6x. Copy the rest. Opposite operation, let's subtract 15 from both sides. Don't lose your negative sign in front of your 6x. And then on the right side, 9 minus 15 is negative 6. We will divide by negative 6 on both sides, and we get x equals 1. Careful with your signs. We have a negative 6 divided by a negative 6. So our answer should be positive. All right, take a minute, substitute this value into one of these two equations, solve for y. Go. All right, hopefully you got y equals 2. That should have been your answer. Okay, so now these next ones are a little different. If you'll notice, I'm given two equations and neither of them have been solved for a variable yet. So we're gonna have to go ahead and do a little bit of work to get one of our variables by itself. So if you take a look, I right away notice all of my variables have a coefficient or a number written in front of it, except for this one. So because of that, this would be my easiest variable to solve for right away. So I'm going to take this equation and I'm going to go ahead and solve it for y. So to do that, I'm going to just quickly draw a line here. All I have to do is get rid of this negative 3x. So I'm going to do the opposite operation, and I will add 3x to both sides of the equation. This way, those two add to 0, and I'm left with y equals 5 plus 3x. So now I have an equation where y has been solved for. So this is the good information that I need. 5 plus 3x equals y. So I'm going to substitute that in for y in the other equation. So let's go ahead and do that. I'm going to move to a different color. All right, so let's move this down here. So I'll have 3x plus 3 times 5 plus 3x, because that's what y equals. And then that whole equation will equal negative 9. All right, let's distribute here. So after I distribute that, I will have 3x plus 3 times 5 is 15. 3 times 3x is 9x. And this all still equals negative 9. I forgot to draw the line. Do we have any like terms on the left side? It looks like we have 3x and 9x. So I can combine those together. That will give me 12x plus 15, and this all equals negative 9. Now let's subtract 15 on both sides. And now I have 12x equals negative 9 minus 15. Use your calculator if you would like. That should be negative 24. Now we'll divide both sides by the number being multiplied by x, which is 12. And we should get x equals negative 2. All right, so now the easiest way that I see to figure out what y equals is I'm going to take x equals negative 2, and I'm going to substitute it back into the equation that has y by itself already. So let's do this. I'm going to take this information and I'm going to put it into that equation. So we have y equals 5 plus 3 times negative 2, since we have negative 2 is equal for x, so I'm plugging it in for x here. All right, so all that's left is to solve for y. So we have y equals 5, and then 3 times negative 2 is negative 6. So this turns into 5 minus 6. and 5 minus 6 is just -1. All right. Not too bad, hopefully not. Let's do another example where we have to solve for one of the variables. All right, problem F. Again, we have two equations. Neither the variable has been solved for yet. If we look up here, I have positive x by itself. So let's go ahead and choose this first equation and solve for x. So I'm going to rewrite it over here. So x, let's try that again. So I have x plus 3y equals -3. So to solve, I just have to do the opposite operation to the 3y. So I'll subtract 3y from both sides, and I have x equals -3 minus 3y. So it's a lot of negatives, but we can do this. So now this is the information that x equals. I am going to plug that into the other equation. So since we just solved the first one, we need to plug this into the second equation. And remember, we're plugging this in for x, okay? So let's use a different color. So I'm going to write this here, -4 times -3 minus 3y minus y equals -10. All right, we need to distribute, so let's distribute our -4 into both of these. So -4 times -3 is +12. -4 times -3y is +12y. And then we still have that minus y, and this all equals -10. Take a look at your like terms. We have 12y and -y. So those can combine. We are left with 12 plus 11y. And that should equal -10. Subtract 12 from both sides. And I now have 11y equals -22. Almost done here. To solve for y, we need to divide both sides by that coefficient, which is 11. So once we do that, you can use your calculator. Y should equal -2. All right, almost done. We still need to figure out what x equals. So we had x solved for here, but we need it to be a number. So let's take our solution of y equals -2, and let's plug that back into this equation and solve for x. So if we go down here, x equals -3 minus 3 times -2, oopsie, because that's what y equals. So x is going to equal -3, and then we have -3 times -2. I see two negatives getting multiplied, so I know my answer will be positive, and 3 times 2 is 6. Simplifying the right side, x should equal +3. All right, go ahead and try example G on your own. So pause the video and try your hand at this one. All right, I got for my answer y equals -2, and then I substituted that back into this equation, and I got x equals 0. So check my work and see if you got the same stuff. The rest of the problems on this page are going to be extra practice. So work on these at your own pace. You can check with your teacher to see if you're getting the right answers, but definitely try all three of these problems sometime and see how you do.